Hello, my name is Matt, and today we're going to be talking about CI/CD pipelines. More specifically, we're going to be talking about what CI/CD pipelines are, how they help you create better software, and how you can get started with a free CI/CD provider such as Azure. And as a bonus, I will provide a link to an example C++ CI/CD pipelines, so you can have something like this, building, testing, and even maybe deploying your code automatically if you have a C++ project. So it's basically just copy and paste YAML files and making sure that your build structure is in the same format as mine, and you should have a pipeline like this. And the link will be on the description, but please watch the video until the end because I'll explain how everything works here so you can understand it and basically add that CI/CD bullet point on your CV and make your employers even more impressed. So let's begin by actually asking the question, what is CI/CD and how does it help you create better software? Well, CI/CD makes the process easier by automating all your development tasks. And before we get too ahead of ourselves, CI/CD stands for continuous integration and continuous delivery / deployment. And it basically means that for every little change that you make in your code, all of the things that I mentioned here, such as building your projects, testing your project automatically, and then releasing your project automatically, will basically happen without your intervention. And to be more specific, things like actually integrating your project, such as building it, testing it, and making sure that you covered enough code in your tests, that is the CI part. And then the CD part is basically just making sure that your software is ready to be deployed to customers. So in the case of a web application, that means that your pipeline is basically going to create a test environment. So your web application will be up and running at the end of the pipeline, so you can go and actually test your software in a real world scenario. But for project in C++, for example, it does change because if you're writing a library or an executable, actually deployment may mean something different, such as, are you making your software available through a package manager like Conan and VC package? And if so, deployment in that case means, can your pipeline create that package automatically and make sure that your customers can install it without your intervention, and so on and so forth. Perhaps I'm not going to touch too much on the deployment part here. I just want you to understand what it is. And as I showed before, a CI/CD pipeline for a C++ project may look something like this, where you may have different stages. And don't worry too much if you don't know what stages, jobs, and tasks are. I will go over that in the future here. But you may have a stage doing some very simple and fast checks, like linting your code and making sure it's up to your syntactical standards. Then you may have a stage building your project. In my case, it actually does mean calling CMake on my project and generating all of the executables and libraries of my project. And then following that, I've got stages for building the documentation here and making sure that is deployed automatically. Then the pipeline also runs all my unit and functional tests and then statically analyzes all of my C++ files to make sure that I'm not doing anything stupid or unsafe. Let's quickly move over to the different types of CI/CD. So I know that there are probably 3 or 4 different terminologies for this, but I split the types into 2 different columns here. And basically we've got on-premise CI/CD, something like Jenkins, where you actually go and download the software and install it on a physical machine, such as a Raspberry Pi or your own computer, in a way that you're going to set it up. So whenever you push to a particular repository, your own physical machine is going to listen for new commits or listen for new PRs, and then pick up all the jobs, all the stages, and run it on that machine. So in other words, you are managing the CI/CD system here. And there are also cloud managed CI/CD and software as a service providers, and these are things like Circle CI, Azure, GitLab, and GitHub CI. And in this type of CI/CD, you don't actually manage the infrastructure of the CI/CD. That is done by providers like Azure themselves, and you just basically get to write your pipeline and get them to execute it. And I've actually gotten a few different features for each of the providers. So you can see here, for example, I've got Jenkins, Circle, CI, Azure, and GitLab. And this is a table comparison between them. The pipeline configuration here for Jenkins is done in something called Groovy, a language called Groovy. Generally, for all the other CI/CD providers that I know of, it's typically a YAML file that you write, and that will define all of your stages, all of your jobs and steps. And obviously, some of these providers do offer a sort of codeless alternative. For example, Azure does have some UI options. So if you don't want to write the YAML, you can go on the UI options and then just click buttons. And for example, you can create a build pipeline without writing any YAML code. Now, most of the platforms that I looked at offer self-hosting. And self-hosting in this particular example means the ability for you to run some of the jobs in your pipeline in physical machines that you own. Obviously, by definition, Jenkins will let you do that because it's an on-premise alternative. But Circle CI, Azure, and GitLab all provide you a way to basically set up your Raspberry Pi or your ARM devices to pick up some of the pipeline elements. For example, if you want to test on a particular device, you can do that with all of these other providers as well. And then you've got things like 3 minutes and whether it's open source or not. So for example, Jenkins, it's unlimited, it's free, it's open source, and because you set it up yourself and you run it on your own machine, you can run it indefinitely. As long as you have electricity, it's going to work. However, Circle CI offers free projects up to 6,000 minutes. Azure offers up to 1,800 minutes, and then GitLab offers up to 50,000 minutes for free. As you can probably tell, I've chosen Azure here. Obviously not because of the 3 minutes, because it offers actually the least amount of 3 minutes out of the other providers here, but because it provides really good Windows integration. So if you're doing Windows builds or Windows testing, Azure is probably your best bet. And because I know that some of you guys are actually developing on Windows, Azure is probably the one I want to recommend for people that just want to get started with pipelines, really. Most of the providers actually use YAML to define the pipelines. In other words, you're going to be writing some YAML code with all the automation steps. And this is an Azure example here for one of my personal projects. And it looks fairly similar to Circle CI's as well, because it is a YAML file, right? It doesn't change too much. And to contrast this, you've got Jenkins, which is groovy, and you can tell straight off the bat that it's quite a little bit different. It looks fairly easy to write a pipeline in it as well, even though I haven't done it myself. I took a look at the documentation. Now, talking about documentation as well, don't worry, because all of the providers, such as Azure, Circle CI, GitLab CI, they all have extensive and very understandable documentation explaining each of these elements and things like how you can create a stage, how you can create a build stage, how you can create a job, and how you can, set up the entire pipeline in a very long, understandable documentation page. And let's actually move on to explain the jargon of pipeline components. I got this image here from a Microsoft blog post, and I'll post a link in the description for credits, obviously. But basically, a pipeline consists of different components. For example, you have a trigger, and it's basically how a pipeline is going to start running. Now, on Azure, for example, you can have triggers on branches, such that every time you push to a particular branch, a pipeline is going to pick up that change and then start the whole thing. You can also have triggers on PRs, and you can also have things like scheduled runs, where you may say something like, every day at 12 a.m., run this pipeline on my main branch or something like that. And then you've got the pipeline itself, which consists of multiple stages, and each stage has a different number of jobs, and you can have multiple jobs, for example. And at the bottom of the hierarchy, we've got, as you can see here, jobs comprised of different steps, multiple steps. And a job is typically picked up by a machine that's running either on the cloud, or if you've set it up locally as a self-hosting agent. And that machine is going to run each of the steps defined in that job. For example, for a CMake build job, that may mean something like, you download all your Conan dependencies, you set up the project so that all the files you checked out, your Git repository, and so on and so forth, and then call CMake on the project that you've just downloaded. And at the very end, you may want to save the files that you've built in an artifact, which I'll explain in a second. It's worth noting that each job here that we've got, and obviously each stage, runs different from the others and is completely independent. For example, the files that you create in a particular job may not be available in the following job. So maybe asking yourself, how do you share build files? How do you share things that you can test later on? Well, these typically are shared by, pipeline artifacts, which is just, the storage method in pipeline. So every time you create a build, for example, you have to publish those build artifacts, which will be your programs or your libraries or your web app, so that the other following jobs can then download that build artifact. And I'm not sure if I mentioned it, but stages do have dependencies. The jobs can have dependencies on other jobs as well. So for example, my testing stage may be dependent on my build stage. So it's not going to run until my build stage is finished, essentially. And I'm going to stop all of the definition stuff right here. I don't want this to take too long, because I do actually want to show you my example here. And as I promised, let's actually get into the example and explain how you can basically set up Azure pipelines on your own GitHub projects. I've posted a link in the description here of a post I've written with my example C++ pipeline. So if you're doing a C++ project, you can basically just copy and paste all the pipeline YAML files. As long as you've got Azure enabled, it's going to work for your project, it's going to build it, and it's going to test everything. Secondly, if you want to get started with Azure pipelines, I recommend logging into GitHub, obviously, and then going to the marketplace and searching for Azure pipelines. If you click on, install here at the bottom, it's going to ask for your permissions. In other words, Azure is going to have permissions to look at all of your repositories on GitHub, it's going to automatically, give you an example YAML file, and it's called Azure Pipelines here, .yaml. I'm going to leave this video here. I will be doing more CI/CD videos in the future, in particular, like explaining each little thing and how you can write the YAML yourself. But this is basically just an introduction to CI/CD. So if you want to learn more about C++, CMake, or even CI/CD, feel free to subscribe. I will appreciate it. And that is it. Bye-bye.